Hello children, welcome to Zero Panic Maths. In today's session, let us continue our discussion on exploring the linear patterns. Okay, in the previous session, if you remember, we have done with the introduction to the linear polynomials and also discussed some of the problems using the exercise set 2.1 and exercise set 2.2. Okay, if you have not watched that video, the link is given in the description. You please watch that video because that is the basic idea. That video gives you the basic idea to understand the concept in this. Okay, now let us continue our discussion on this, exploring the linear patterns. So now if you see in the previous session also, we have seen some generic statement which looks like a linear polynomial or an algebraic equation wherein change in one variable will change the whole value of the expression in a constant way. Okay, that is the constant growth or constant decay in the value. Okay, now if you see that here also in stage 1, now let us assume this growing pattern of the square tiles. Okay, there is a square tile here. At stage 1 there is one tile. Okay, at stage 2, okay, listen to me carefully here. At stage 2 there are two tiles which are added. Now assume that if you add a tile here and add a tile here, this becomes the second stage. To the second stage, if you add a tile here and add one more tile here, this will become the third stage. So if you see at every stage there is an increment of two tiles after stage to stage. Okay, now this can be generalized in a form that at every stage, if you observe, it is 2 into 2 minus 1, right? 2 into 2 is 4 minus 1, so it is totally 3 here. Here also 3 into 2 minus 1, correct? It is 2 times the stage minus 1. So here also if you see, it is 4 into 2 minus 1. 4 into 2, it is 8 minus 1. If you see, it is 7. Okay, so this table actually gives the information of that only. At stage number 1, it is only one tile. At stage number 2, it is 2 into 2 minus 1, that is 3. 3 into 2 minus 1, 5. 4 into 2 minus 1, 7. So in this way, if you consider, each stage is obtained by adding two more tiles to the previous stage, as I have already explained here. Okay, two tiles are getting added at each stage, and this actually leads us to a linear expression 2n minus 1. Okay, where n is 1, 2, 3, the number of stages. Okay, and also an example of a linear polynomial. So this can be considered as a linear polynomial 2n minus 1 with degree 1. Okay, so here we can see a relationship between the stage numbers and the number of square tiles. And what is that relationship? That relationship is called as a linear relationship because there is a linear growth in the value of number of square tiles as compared to, or as and when the growth in the stage number appears. Okay, when the stage increases, this number of the square tiles also increases in a linear fashion. And what is that linear fashion? Is 2 at each stage. 2, 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7. So this is what is called as a linear pattern, and a linear relationship exists between this two. Okay, so we will see some more examples containing the linear patterns and try to identify the linear pattern that exists between one input to the output, you can say. Okay, so let us see what example 7 says. Bela has rupees 100 for packet money. Okay, she already has a pocket money of rupees 100. She spends 5 rupees every day. Okay, rupees 5 every day. And the question is, after how many days will she be left with rupees 40? Now the question is very, very simple. You need to just go on deducting 5 rupees on every day from 100 rupees. Okay, so there is a table that actually gives the day numbers on the first row and the amount left on the second row. Okay, you see that day number 0. So initially she has 100 rupees here. At day 1, she spends 5 rupees, because that is what is given as an information in the problem. Okay, so the amount left on the day 1 or at the end of day 1 is always calculated as 100 minus 5, correct? It is 95 rupees, right? Now similarly, on the second day she spends another 5 rupees, and that we can write it as 5 into 2 on the second day. Okay, of course it can be 95 minus another 5 also, that also gives us 90 only, but I am writing it as 2 times 5, because on 2 days she has spent 5 rupees on each day. Okay, that also gives us 5 into 2 10, that is 100 minus 10, and that is 90, which is equal to 95 minus 5 only. Similarly, following this pattern only, on the third day also we can say 100 minus 5 into 3 times, because on 3 days 5 rupees she is spending, and it is 85. Similarly, if you continue on the fourth day also, we will get it as 4 times 5 rupees, and it is 20, which is deducted from 100, and it is 8 rupees. Now continuing in this fashion only, on the nth day, if you observe here, on day 2 it is 2 multiplied. Here also on day 1 you can say it as 5 multiplied with 1. On day 3 we are multiplying it with 3. On day 4 we are multiplying with 4. Okay, and all the other remaining values here in this equation are constant only. It is 100 rupees, which is her initial pocket money, and 5, which is the amount that she is spending on every day. Okay, so in general, if you continue in this fashion only, we can write it as initial amount. Okay, I will write it in a descriptive way. Initial amount is equal to rupees 100. That is on day 0. That is on day 0 here. Okay, amount remained on amount left, you can say amount left on day 1, amount left on day 1 is equal to 100 minus 5. Okay, that is 95, you can say 95 only. Okay, and similarly amount left on day 2 is equal to 100 minus 5 into 2. We know that. Okay, and we have the value it as 90. Similarly, amount left on day 3, it is 100 minus 5 into 3. Now if you observe here, there is a pattern that it is going on, that on nth day it is 100, which is also constant, 5, which is also constant, and n, which is getting increased from the first day to the nth day. 1 2 3, on first day 5 into 1, on second day 5 into 2, third day 5 into 3. So similarly on nth day it will be 100 minus 5 into n. Okay, so using this formula only, for any given day we can find out the amount left. Okay, so for consider this as a formula, that amount left on day n is 100 minus 5n. So therefore we can say that the algebraic equation, that is equating the equation, we can write equating 100 minus 5n, 100 minus 5n equal to 40. Okay, and finding the n value, in that algebraic equation actually gives us the required answer. Okay, let us resolve this. Okay, now this equation, take minus 5n to the right side and take the 40 to this side. That actually gives us 100 minus 40 is equal to 5n. That is actually equal to 5n is equal to 100 minus 40, that is 60. So therefore you can say that 5n is equal to 60, and n is equal to 60 divided by 5, that is equal to 12. So it means that after 12 days, after how many days it is asked, right? So therefore you can write after 12 days she will be left with rupees 40. You can even verify that also later. Okay, so let us write the answer first. Therefore after 12 days, after 12 days, uh, Bela will be left with, will be left with 40 rupees, left with 40 rupees, or you should be writing it as rupees 40. Okay, this is actually the answer. How can you verify this? Just substitute 12 into this equation. You see that 5 into 12, 12 5 is 60, 100 minus 60 is equal to 40. Let us see the next example. This example is little bit different from the previous example. That you can see from the first and second point, it is the same value that is remaining here. Okay, let us read the problem first. An auto rickshaw fare start at rupees 25. Okay, there is an auto rickshaw fare and that starts at rupees 25 and remains the same for initial 2 kilometers. Okay, see there is a table given here. Kilometer traveled, first kilometer traveled, it will be 25 only. After second kilometer also, after 2 kilometer also, it will be remaining it as a 25 only, because auto rickshaw charges for the first 2 kilometers it is 25 rupees, same value. Okay, but after second kilometer, after 2 kilometers, per kilometer there is a different fare. Okay, so then it increases by rupees 15 per kilometer. So as I said, after 2 kilometers, 15 rupees per kilometer it is getting increased. You can see that. Okay, what will be the fare for a travel of 10 kilometer? The answer we need to find it out. Okay, let us see the table first. Okay, so the first kilometer and second kilometer 25. Okay, after third kilometer it is the 15 getting added to the 25. And how is the 15 getting added? It is one time 15 which is added to 25 plus 15, which is 40. In the second, again two times the 15 quantity 15 is getting added to the 25, which is 25 plus 30, which is 55. Similarly, if you go on continuing, okay, you can observe that at every stage the fixed amount 15 rupees is getting increased. Okay, but that there is a condition that it is only for the value greater than or equal to 2. Till 2 it is remaining 25 only, but after the value 2 for the kilometer traveled, it is getting increased by a constant amount, and that constant amount is 15, and that is the relation. Okay, you can see that here. You can see that here. Now you can see, observe that the total fare for travel of n kilometer. So how do you derive the algebraic equation for calculating the fare? Okay, the total fare, that will be fixed 25 rupees, and to that 25 only you are going to add 15 rupees and multiplied with not directly n, but it is n minus 2. In the previous example, if you remember, for every stage we were actually adding, see, for every day we were actually multiplying it with the same n only, but here it is not that case. That is the reason I told you this is a little bit different, because for the first 2 kilometer traveled it remains the same. So that is the reason. For the third kilometer it is 3 minus 2. You see, 3 minus 2, 1 is getting multiplied here. Here also 4 minus 2, 2 is getting multiplied here. 5 minus 2, that is 3 is getting multiplied here. So the overall equation is this one. Overall equation is this one, that is 25 constant plus 15 rupees, that is per kilometer charge, but that is after n minus 2 kilometers. N minus, where n is the kilometer traveled, and third kilometer it is 3 minus 2, one time 15 rupees is added to the 25. Okay, hope you are getting it. Okay, now how did we got this 15n minus 5 is by actually resolving this equation. Okay, now let us resolve that equation quickly. It is 25, okay, plus 15 into n, that is 15n, minus 15 into 2, that is 30. Okay, so it is 25 minus 30 remains as minus 5, and 15n minus 5. So this is that equation. 15n minus 5 is the actually the nth term linear equation in n. It is the nth term linear equation in n. Okay, by substituting the value of n, we can get the fare calculated for any number of kilometers. Okay, so finally we can say that a linear pattern is a sequence of numbers where the difference between the two consecutive term is constant. So that is the definition given for the linear pattern. So what is the linear pattern? Linear pattern is a sequence of number where the difference between the two consecutive number is a constant. You can see that the difference between the two consecutive numbers, 55 minus 40, it is 15. 70 minus 55, 15 only. 85 minus 70, 15 only. So there is a fixed constant that is a difference between the two consecutive numbers. So such a sequence of numbers is called as a linear pattern. Okay, now coming to the answer to the question asked in this problem is, what will be the fare for a travel of 10 kilometer? So as I told here, so the cost of 10 kilometer, cost of, or you can say fare of 10 kilometer, fare of 10 kilometer is, substituting 10 into this equation, is equal to you can say 15 into 10 minus 5, that is 150 minus 5, that is rupees 145, rupees 145. You can say this, correct? Okay, now let us see the problems based on this. Okay, now we will see some of the problems in exercise set 2.3 which are based on the concept of a linear pattern that what we have studied till now. Okay, now let us see the first problem quickly. A student has rupees 500 in her savings bank account. Okay, so initial amount is 500. So this problem and all the problems in this exercise set are all based on the linear pattern only. We need to identify the equation for the linear pattern and you will get the answer. All problems are similar in this exercise set. Okay, so student has rupees 500 in her savings bank account. She gets 150 every month. Another additional 150 she is getting on every month as a pocket money. Okay, now how much money will she have at the end of every month? We need to calculate, or as I told, we need to derive an algebraic equation or a linear polynomial representing the linear pattern in this problem. Okay, from the second month onwards. So from second month onwards, how much money she will be having? Find a linear expression. They are asking that linear expression only represent the amount she will have in the nth month in generally. Okay, so let us start with the problem. Initial amount is equal to rupees 500, right? Initially she is having an amount of rupees 500 in her bank, and after every month she is going to get 150 rupees added to this. Okay, after month 1, you can say after month 1, in general after month 1 it is 500 plus 150, correct? 500 plus 150. After month 2, okay, you can see, you can observe a linear pattern here. 500 initially she had, and after 2 months 2 times 150 she is going to get. So I can say it is 150 into 2, or it is actually as good as adding 150 to the 650, which is the amount after first month. Okay, both are same only. Here also you will see, to the 650 if you add 150 you're going to get 800. Here also you are going to get 800. 500 plus 150 into 2, it is actually 800 only, correct? Because I want to have a linear pattern identifying the expression, finally I am writing it in this format. Okay, you're getting this right? Okay, now similarly, I can say after month 3, it is just 500 and 150 times the third month, which is 450 plus 500, 950, and the same 950 you are going to get it by adding 150 to the previous amount 800. So there is a constant value that is getting increased every month, and that constant value is 150. You see, 500 to 650, 650 to 800, 800 to 950, it goes on increasing in that format. So finally, at the nth month, you if you continue in this format only, after month n, in place of 1 2 3 4, you just place n. It will be, the answer is 500 plus 150 and n, where n is the month number and 150 is the initial amount, sorry, 500 is the initial amount and 50 is the constant increase or every month pocket money. You can say 150 is the every month pocket money. So this is the expression. So what is the answer? Finally, expression to represent the amount she will have in the nth month, or I can directly write, therefore nth month amount, nth month amount, or you can say expression for nth month amount, because that is what they asked, right? Expression for nth month amount is equal to what is that expression? 500 plus 150 n. So that is the answer. 500 plus 150 n, where this you can write, where it is, this is the initial amount. You can write it in words, right? Initial amount, okay, and this is the every month pocket money, every month pocket money, and what is n represents? N represents the month. N represents the month. Okay, this is how you're going to resolve this. Okay, let us quickly see the next problem. Okay, so this also, as I already told you, this problem is also resolved in the same fashion. Okay, only the data are different. Okay, now read the problem carefully. A rally starts with 120 members. A rally starts with 120 members. Okay, each hour, read it carefully, each hour 9 members drop out of the group. Okay, so there is a rally going on and there are 120 members listening to that rally, but after every hour 9 members are dropping out or going out from that rally. Okay, how many members will remain after 1 2 3 hours? Okay, we need to calculate that. Okay, and find a linear expression to represent the number of members at the end of nth hour. Okay, do you feel that this is exactly similar to the previous problem? Okay, it is exactly similar to that only. Let us see and let us plot the table for that. Okay, hours in the first row I've taken and remaining members in the second row. So for the 0th hour, that is when the rally starts, what is the total number of members it exists there? It is 120 members. After 1 hour, as it is said here, after 1 hour 9 members will drop out from that. So how can I represent that in an expression? It is 120 minus 9, or you can say 9 into 1, for to just to coincide with the value of hours, that is 1, and 120 minus 1, what is the value that remains? Is 111, correct? 120 minus 1, 111. Okay, now similarly after second hour, as you know, it is 2 times 9 members. Okay, 9 members after 1 hour, 9 members after second hour, they went off, so it is the value like this. Okay, it is 102. Okay, similarly after third hour, after third hour, it is 129 multiplied by 3. So because it is the n times 9, okay, we will be getting some value here. Okay, So similarly, if you go on doing this way, I'll just replace this 1, 2, 3 by n, and that is the expression that is needed here. Okay, what is that? It is 120 minus 9n. Okay, so that is how you derived the nth term or nth hour, the members remaining after nth hour. Okay, you can see that. Okay, if you want, you can write it in the similar fashion as we written it for the first problem. Let us write it for this problem. The third problem onwards, I will not be writing it. You have to write it yourself. Okay, so I can write it as initial members. Okay, initial members is equal to 120. Okay, members after hour 1, members after hour 1, that is 120 minus 9. 120 minus 9. Members after hour 2, it is 120 minus 9 into 2. Let me write this as 9 into 1. You have to write the total value also here, okay, by looking at the table. Now similarly, after hour 3, it is 120 minus 9 into 3. So similarly, after nth hour, okay, you have to write it in this fashion. After nth hour, just replace that 1, 2, 3, the ongoing number with n. So that is 120 minus 9n. So finally, the expression needed, okay, you can see that the expression to represent, therefore expression to members after nth hour, members after nth hour is equal to 120 minus 9n. And you can write 120 is initial member, 9 is the members dropped for every hour, and n is the number representing the hour. Okay, you have to write that. So this is the answer to this question. This is exactly similar to the previous question only. Now even the third question. Okay, now let us see. Suppose the length of a rectangle is 13 centimeter. Okay, this problem is a little bit different from the previous two problems. You see that suppose the length of a rectangle is 13 centimeter, they have given, and find the area if the breadth is, there are three different breadth values given: 12 centimeter, 10 centimeter, and 8 centimeter. Okay, this is not that big task, because we know that the area of the rectangle is length into breadth. Length is fixed 13 centimeter. So here you can say that length is given as 13 centimeter only. Length is equal to 13 centimeter fixed, and for 12 centimeter, once you consider 12 centimeter, area is equal to 13 into 12. Okay, that is 13 times 30 plus 26, that is 156 centimeter square. Okay, that is the answer to the first question. Second question, similarly for the second question, okay, let me quickly find out the area by keeping 13 as the length and substituting different values of width for every question. It is 130 centimeter square. You can see that. Okay, for the second question, it is 10 centimeter width they have given. Similarly, for the third question, area is equal to 13, which is length, which is fixed, and 8. Okay, uh, 13 8 it is 104, correct? 104 centimeter square. Okay, since it is the area, we are defining it as a centimeter square. Okay. Okay, now if you look at the pattern here, you see that find the linear pattern representing the area of the rectangle. Finally, they are saying after calculating the values for this, you are substituting the different values of width. Suppose this width is considered as W, and area is considered as A here. What you see is 13 is fixed and W is getting different in all these values. So what expression we can derive by using this? Okay, simply so if area is equal to area of rectangle, right? It is a area of rectangle. Area of rectangle is A and width as W. Width as W. If we represent width as W, you can see that according to this problem, length is fixed, which is 13. So 13 length into W, that is area. Okay. So the linear pattern is equal to, you can directly write that linear pattern that is observed in this problem, linear pattern is equal to area is equal to 13, which is length, and W is this pattern. Or you can say A is equal to 13W. Directly you can write this also. A 13W is the pattern that is observed in this problem. You understood this? Okay. So it's a simple example, just with a little bit of different information they have asked this. So similarly, we have another question which actually is related to the volume of the rectangle. There it was area, here another dimension, height is added to the length and breadth, and you are asked to find out the linear pattern here also. You see, read the problem carefully. Suppose the length of the rectangular box is 7 centimeter. Here also the length is given as 7 centimeter, that is fixed. Breadth is also given as 11 centimeter, that is also fixed. Find the volume. Okay, we need to find the volume, and we know that volume of the rectangle is all the dimensions multiplication, length, breadth, and height. If you multiply length into breadth into height, you're going to get the volume of the rectangle. Okay, but height here in every problem is getting deferred, keeping the constant length 7 centimeter and breadth as 11 centimeter. So that multiplication of length into breadth is constant only. Okay, only the height is getting deferred here. So based on that only we need to identify the linear pattern. You understood this, right? Okay, now let us write in general that we know that volume of the rectangle is equal to length into breadth into height. Correct? Length into breadth into height. So we can say here that say V is equal to, if you consider V it as volume of the rectangle, length is 7 centimeter, which is fixed, and breadth is 11 centimeter, which is also fixed, and we are going to get H. So V is equal to 77 H. So this we can write it as a linear pattern that is observed here. 77H, considering V as the volume of the rectangle and H as the height of the rectangle. You can write it yourself. Okay. So the last part only I have resolved it first. Considering V as the volume of the rectangle and H as the height of the rectangle, since length and breadths are given, 77H will become the linear pattern for this problem. Understood this? Okay, now let us resolve the values. By using this formula only, we can resolve 1, 2, 3 equations. Okay, sorry, the problems 1, 2, 3. Problem number 1, for 5 centimeter, the volume is equal to length into breadth, that is actually 77. Directly we can write 77 into H, that is 5. Correct? Okay, so 5 times 7. Okay, 5 sevens are 35. 5 sevens are 35, 5 sevens are 35, and 3, that is 38 centimeter cube. It is centimeter cube, for 385 centimeter cube. Okay, you know that. Okay, now similarly, because it is volume, 3 times 1 centimeter for length, 1 centimeter for breadth, and 1 centimeter for height. Centimeter into centimeter into centimeter, that makes it as centimeter cube. Okay, if you don't know why centimeter cube is considered for volume, So again for the second case it is 77 fixed and multiplied by 9. 77 nines are, okay, so 9 sevens are, it is 63, and 9 sevens are 63 and 6 it is 69, okay, centimeter cube. Okay, for the third problem, it is volume is equal to 77 times the height, that is 13. Okay, 13 sevens are, that is 91, 9 carry here, 13 sevens are 91 plus 9, that is 100. Okay, 1001 centimeter cube. So this is the answer for all the three problems, or for all the three different heights. This is the volume. Okay, and as I already told, considering volume, you can write it here, considering volume. So if volume is equal to v, volume is equal to v, and height is equal to h, height is equal to h, therefore volume v is equal to 77h is the linear pattern, is the linear pattern for the required problem. You can say that. Generally you can write it, linear pattern for the required problem. So you can write it in any way that is convenient for you. Okay, so this is the fourth problem. Okay, now let us look at the fifth problem. Sarita is reading a book of 500 pages. Okay, so similarly the problem differs, but it is also the concept of linear pattern, identifying the linear pattern only. Okay, Sarita is reading a book of 500 pages. She reads 20 pages every day. Every day she reads 20 pages. How many pages will be left after 15 days? She after reading for 15 days, how many pages will be left, and express this as a linear pattern. Okay, now let us first try representing it in a table. Days in the first row, 0th row, when she started, how many pages will be remaining? 500 pages, because she has not yet started reading it. Okay, after the day 1, because for every day she is reading 20 pages, I can say 500 minus 20, and that is 480. Correct? The linear pattern here is 20n. Okay, that's all. Okay, after second day it is 20 multiplied by 2, because 40 pages she will be reading it, and 460 is the page remaining. After third day, okay, 20 pages multiplied by 3, that is 60. 500 minus 60 is 440. Okay, similarly after nth, just replace 1 2 3 by n here, so that is 500 minus 20 times n, and that is the actual linear pattern. Okay, and expressing that in a linear pattern is 500 minus 2n. Okay, now let us write that in a descriptive way. Okay, we have written it for all the problems, let us write it here also. Okay, initial pages, you can write it as initial pages in book is 500. Initial pages is 500. uh, uh, Pages left after day 1, pages left after day 1 is 500 minus 20. Similarly, pages after day 2, it is 500 minus 20 into 2. Okay, you have to write it in this descriptive pattern, because this is the problem for descriptive answer. Okay, so 500 minus 20 into 3. Okay, and so in this pattern, if you consider after nth day, it is 500 minus 2n, and this is the linear pattern that is observed to represent this problem. Okay, you understood this? Okay, so you can finally write this as an answer, linear pattern 500 minus 2n. But what is the problem that we are left with is how many pages will be left after 15 days. Okay, so therefore by using this formula only, the pages left after 15 days, so the pages left after 15 days, after 15 days is equal to substituting 15 in place of n in this expression. You have to write this as an expression. Okay, you have to write that, remember that. Okay, so it is 500 as the initial pages and 20 pages every day, and after 15 days how many pages she will be left with? That is 500 minus 20 into 15, that is 300, and it is 200 pages that she will be left with after 15 days. Understood? So hope this is the last problem in this concept. Okay, this, so that was the last problem in that concept of identifying the linear patterns in the linear polynomials. Now the next concept is linear growth and linear decay. Okay, in all the problems that what we have discussed till now, we have already gone through the concept of linear growth and linear decay. Now if you observe carefully for the previous two problems, you see that here in this problem the constant decrement in the initial value is getting done. Okay, so what is the constant decrement? From 500 to 480 it is 20, again 20 from 480, again 20 decreased from 460. So that way 20 is the constant value that is getting decayed. That is what is called as linear decay. And if you see for the previous problem, here if you see for the initial amount in the savings bank 500, a constant amount 150 is getting added every month. It is got called as linear growth. So for the initial amount, if a constant amount is getting added and the values are growing in a linear fashion, that is called as linear growth. And if a constant amount is getting decreased after every fixed duration, then that is called as linear decay. Okay, so in case of linear growth, a fixed amount of value is getting increased in a linear fashion, and in a linear decay fixed value is getting decreased. Okay, so this is the concept which has little more examples to discuss, and there is a fixed exercise set also onto this concept. Okay, now we have completed the linear pattern and the exercise set 2.3 in this session. Let us see this concept of linear growth and decay and the exercise set related to this in the next session. Okay, thank you.